Grade 12 college prep physics. This is the final new lesson of the year. I'm going to do one more review lesson related to this unit, but this is the last bit of new information of the whole year, which is kind of cool. So here we go, fluid flow. No math really to this one either, but it's a pretty cool concept what we're getting into. Not this I don't find so much, this is just definitions, but one term, and again, as a chemical engineer, I talked about this all the time. Viscosity is a huge deal, and it's just how nice something pours usually is viscosity. So and it's a measure, it's a number. We don't deal with the number in class, but if you hear the term viscosity, like molasses, high viscosity. Water, fairly low viscosity, and you can imagine there's some fluids with even lower viscosity. Two terms related to how things flow, and again, I'm thinking mostly this is a real engineering sort of designed focused unit, and like moving things in pipes is a big deal if you're an engineer, right? Getting fluid from one place to another. So laminar means it's moving slowly, which is usually more beneficial because you have more control of the situation. You have less friction. Turbulent flow is the alternative to laminar. It's laminar or it's turbulent. Turbulent is really not smooth. It's the opposite of smooth. So turbulent, when I look at turbulent, this is the picture. You have, it's called, these little things are called eddies right down here, where everything's all splashy and difficult, right? That's turbulent flow. And that would be a picture of turbulent flow. It's just not flowing straight. So you can imagine there's energy lost in that process. Usually, though, there's always this balance. And as an engineer, you want laminar flow, but you want it to go really fast. And typically when things go fast, you end up with turbulence. Or if it turns around a corner, right? Your pipe goes through a corner and now you've got turbulence. You don't have nice smooth laminar flow anymore. So one thing, kind of an interesting physics thing is, most new physics is all looking at quantum physics, like very tiny, like subatomic particles, like smaller than the atom. And the idea in 1905 when Lord Kelvin said that, physics is done, we know everything we need to know. He was talking about classical physics, which is really the physics we talk about in this course. It's like, we know everything, not me, but, physicists know everything they need to know about just regular physics, enough to get to the moon, and that's true. However, they say there's one topic that's not thoroughly understood in classical physics, and it's turbulent flow, which I think is kind of interesting. Like really being able to understand and predict turbulent flow is something that there's nobody on Earth, apparently, who can really do a very good job of that. Maybe one of you guys will be the first. Okay, a couple more terms you need to know. The force drag, you've probably heard that before. It's just another way of saying air friction. And, obviously the objective of streamlining is to reduce turbulence because drag is friction, and usually you don't want that. Friction means you're turning energy from some sort of kinetic, useful energy to heat. Okay, so this is where things are kind of cool, though. This is the part we get to learn something new and do cool stuff with. Is a concept called Bernoulli's principle. And it says that where the speed of a fluid is low, the pressure is high. And where the speed of a fluid is high, the pressure is low. And you're saying, so? Okay, that's wonderful. Pretty neat, some of the things that come out of that. So if I took a pipe, though, and this ends up being called something called a Venturi meter, which we don't need to understand in this course, but you can calculate pressure based on the difference in speed. Like if I want to know the pressure right here, I could, based on the difference in speed as it goes through here, and I could do that through difference in pressure, I could measure things. So if this same amount of fluid goes through this small little opening, it's got to go really fast to get through, right? So therefore, it's got a lower pressure. Where here you've got really high pressure. But let's see some better examples of that. Bernoulli's principle is the reason why an airplane flies. So if this was a cross-section of a wing, okay, what happens is you've got, the wing, that basically this flies into the air. So this is sort of the relative motion of the air around the wing. And that air has to get split. Some of it's got to go over this part, and some of it's got to go underneath. Since this air, the top air, has a further, like a longer path to travel, it's got to move faster. Where this air has a lower shorter path to travel, so it can go a little bit slower. But if this air is slower, that means it's higher pressure, and it's going to push up. Whoopsie, push up. And then this will have low pressure. So I'm going to have low pressure air down here, high pressure air up here, and that's why our airplanes fly. So when you go on your next vacation, maybe over Christmas break, you're going on vacation, you can think to yourself, really happy for Bernoulli's principle, because that's how you're getting there. Anyways, I do have a little video.
Have you ever sat in the seat of a jumbo jet and wondered how it's able to fly through the air while loaded with passengers,
Yes.
cargo, and fuel? Let's take a closer look at how a wing is able to lift airplanes both large and small off the ground. As an aircraft's wing slices through the air, it pushes air over its top and under its bottom surface. A wing's curved shape is designed to cause air to move at a higher speed over its top surface compared to its bottom surface. A principle in physics states that faster-moving air has lower pressure than slower-moving air, meaning that there's more pressure on the bottom of the wing than on the top of the wing. The higher pressure air pushes up on the bottom of the wing, and the result is lift. The angle of the wing relative to the air that it slices through, called the angle of attack, also contributes to the wing's lift. A wing at a higher angle of attack generates more lift than a wing at a lower angle of attack. When an aircraft begins takeoff, its wing produces no lift because there's no air flowing over it. However, as the aircraft's speed increases, the wing generates more lift, and when the pilot increases the aircraft's angle of attack, the plane lifts off. The next time you're flying in the sky, you'll appreciate how an airplane's wing is lifting you to your next destination. Happy flying. For more information on this topic and many others, please visit.
Funny. Bernoulli's principle, why an airplane flies. Okay. Okay, so this is a typical problem. This is probably one I wouldn't give you, but it's at least a good example. So I was talking about this being the shape of a Venturi meter. It is used to determine the velocity of fluid through a pipe. So describe how that would be possible. So again, look, this looks like a manometer, right? So if you could measure the pressure difference between these two areas, you can tell by how much pressure difference is the relative speed. Okay? This one I'm going to leave, you can ask me about, but this is like, I like this one, and I do think you should try it on. But if you think about this is spoiler, not a movie spoiler, but does the spoiler shown, this is the spoiler right here, result in an upward or a downward force on the rear of your car? Okay, so I want you to answer these questions, write down your answers, and if you want to talk about it, just call me over. I'd like to talk to you about it. And to help keep a car stable when traveling around curves, why would you use that? Okay? Nope, I have the answer. I wanted you to try it. I'm not going to show you the answer. You try it. Come talk to me. Call me over and we'll talk about it. Okay? You saw the answer to the first one. Okay. Some spoilers are designed just for appearance. And describe the disadvantage of having something that's just there for appearance. Anyway, so try those questions, and then I want that as part of your hand. And like when you hand in your final assignment, will be the package will include those answers. And just again, call me over if you want to talk about it. Okay, this is the review section of the next lesson, so I'm going to stop here, and the review you can do next time.